Hi, everyone. Today we're going to look at some more polynomial analysis with zeros. And we're going to look at the whole complete analysis. We're going to look at a cubic and we're going to look at a quartic. One of them is going to have some repeating roots. So let's take a look. Okay, so this was sent along with this video. This deals again with complete analysis. There are several steps. So let's start with example 1. We have f of x equals 2x cubed plus 3x squared minus 29x plus 30. The leading term is 2x cubed, and since it's positive, the end behavior would be based on odd ordered polynomial of x cubed, and it goes down from right to left and up from left to right. The rational root possibilities, all the factors of the 30 are a p, and all the factors of the 2 are q. We divide each one of those out, p over q, and we get all of these possibilities. Plugging in, I find that I have a 0 at f of 2, f of minus 5, and f of 3 over 2. Now, that's nice because that's 3 zeros. Since it's a cubic, that's the most number of zeros it can have, and they're all rational. So let's verify each. Okay. So for 2, we do the synthetic division. I want you to make sure to realize that this answer you get down here, that's a polynomial itself. And so since we started with a cubic and we divided by one root, we get a square. So that'd be 2x squared plus 7x minus 15. And the same thing here when we divide out with the 5. We get, that's just some extra pen there, that's not a negative. We get 2x squared minus 7x plus 6 for the resultant. Since our remainder is 0, that means that it divides out. And the same thing here when we divide by 3 over 2. We get 2x squared plus 6x minus 20. I want you to keep that in mind because that's going to be helpful when we actually look at repeated roots. Okay, so we're going to factor using the minus 5, the 3 over 2, and the 2. Okay, so remember when you put it in factored form, you change the sign of the 0. So since it was minus 5, it becomes x plus 5. Since it was positive 3 over 2, it becomes x minus 3 over 2. And since it was x equal 2, it becomes x equal x to minus 2. Okay, we'll write it in factored form. So then let's take a look. Okay. We have multiplicity of 1 for each. We go through minus 5. We go through 3 over 2, which is 1.5. And we go through 2. Okay. And so since that's the case, okay, we have some ups and downs looking at the end behavior. So since we go through minus 5, it has to turn back around and go back to positive 1 over 2. And since we go through positive 1 over 2, it has to turn back around and go through 2. So finding those peaks and valleys, the peaks are called local maxes. The valleys are called local mins. This can be done by using by graphing it on your calculator and then using the trace key, or better yet, the calc key. The calc key is a second function of the trace key. And to find maxes, you press second and calc and number 4, and you set the left and right bound. That max has to be between those two. In this case, we end up, once we do that, we go through the process and press enter. We get minus 2.75 for the x value and 90.84 for the y value. For the min, same thing, except you choose number 3. Note, typically we describe local maxes and mins by stating the x value. Okay, we typically don't state the y value unless it says, and how much is this function at that value. Where does the function increase and decrease? It doesn't increase or decrease at max and mins. It does neither, so we have an open interval there. And so when I go back and look at the function, okay, it starts way back here at negative infinity, way back here at negative infinity, increase, increase, increase. Hits that local min, does neither, or max, does neither, then goes back down, 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 hits the local min, not going down or up at that instant, then goes back up. Okay, so it increases between negative infinity and this local max of, what was it, minus 2.75. And then it decreases to this local min, and then increases beyond that. So the local min, if we recall, was at 1.75. So it's going to increase from negative infinity to minus 2.75. Then it decreases from minus 2.75 to 1.75. That's where the min hits. And then it goes back to increasing 1.75 to positive infinity. It doesn't include any points. Okay, it doesn't increase or decrease at the max or min. What about repeated roots? Okay, repeated roots are a little bit trickier. Okay, you don't always know if you have, just because you end up with 1, 0 doesn't mean that you have repeated roots. You could have complex numbers as your zeros, or you could, you could have a scenario where, they're not rational roots, okay? Like square root of 2 or something. And so x to the fourth plus 3x cubed minus 3x squared minus 7x plus 6. Our leading term is x to the fourth. The behavior goes up in both directions, as it would with an even ordered polynomial. Our p's and q's, 1, 2, 3, and 6 for the p's, and plus and minus 1 for the q. So we get 1, 2, 3, and 6, plus and minus for all of those. 1 gives us a 0, minus 2 gives us a 0, and minus 3 gives us a 0. So there are 3 zeros. So that means we could have a repeated root, we could have something that's irrational, or we could have a complex 0. Remember, this process, this p over q stuff, just gives us rational roots of an integer divided by an integer. So let's see if we can figure this out. Okay, so at minus 2, okay, we end up with verifying it. Now I want you to note here, we have a 1, 1, minus 5, and 3. So we divided by a factor of really x plus 2 for a 0 back at x minus 2. Okay, so we divided a first power into a fourth power, so that gives us a cube. So we have an x cubed plus x squared from the ones here, a minus 5x and a 3. We can use this now to verify the next one. We'll verify minus 3. So minus 3, we divide out, and we get a 1, a minus 2, a 1, and a 0. So that 0 means it's a root, it's a 0, no remainder, and this would be an x squared, a minus 2x, and a 1. Why? Well, because, again, we actually divided out by a first power. We divided with a first power into a cubic. That gives us a square. Now, interestingly enough, once you're here, you could try to factor this or use a quadratic formula to verify the next 0. Okay? But if we continue on and use this for the next 0, we verify 1, we get 1 minus 1 and 0. This means x equals 1 is one of the zeros. Now, if I take that final form that I got here, after I divide it down, 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 I take that final form, okay, and I look at it, that's x minus 1. That has to also be a 0. So since it's a 0, I set that equal to 0 and solve. And that gives me x equals 1. So that means the 1 happened twice. Since it happened twice, it's the repeated value. So let's factor that. So we have the repeated x minus 1. So that means we have the quantity x minus 1 squared, then x plus 2, and x plus 3. X equal 1 has multiplicity 2. So what does that mean on the graph? At x equal 2, it touches the x-axis, but it doesn't go through it. And so let's take a look. So we go through minus 3 and minus 2. And then we go down, just touch the graph at 1, and then go back up. And so here's our end behavior, up and up at the ends. Goes through minus 3, because it had multiplicity 1. Curves back around, goes through minus 2. Goes up, 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 curves back around to get down to minus 1, or to get to positive 1. Just touches minus 1, and then goes back up. So it increases from minus infinity, or I'm sorry, decreases from minus infinity to whatever this value is for this local min. Then it increases from that local min to the local max. Then it decreases again from that local max to this next local min, because that's a valley as well. That's a low point as well. And then it increases after that. So to find the local mins and maxes, We go through the process with second and calculate. Number 4 gives us the max. We set our boundaries. We find the max is at x equal minus 0.68. We have 2 local mins. We have this left one, and we have this right one. Now, we kind of have an idea. We should have an idea what the right one is. Since it just touches the graph there and curves back up, it's going to be whatever the x value is, and the y value is going to be 0. Okay? But here, it's in between 2 zeros, so I don't know quite what it is yet. So we go through the process. We set our left and right bounds, and it tells me it's at minus 2.57 approximately, and it gives me a y value of minus 3.12. Now I want to know what that y value is so I can set my window correctly to get a good graph. Okay? And so to find the other one, it just verifies it's at 1, 0. So we increase from the first minimum, the first local minimum, to the maximum, the local maximum, and then we increase again from the next local minimum to infinity. We decrease from negative infinity to the first local minimum, and then we decrease again from the maximum, the local maximum, to the next minimum. Okay, hopefully this helps out. Have a good day, and we'll see you next time. Next time we'll actually talk about applications, and we'll do a couple more, maybe one with a complex 0.